Yes, good afternoon. So in last class we were discussing about the like the solar cell and how solar cell is basically the like any basic unit for any solar energy generation system, and how when the required intensity of light falls on the solar panels and by achieving the the potential difference that is of zero point 0.5 volt, the intensity, depending upon the intensity of the light, the current capacity of the cell can be measured. Okay, so we have seen the VI characteristics also, and depending upon that VI characteristics, we are going to study about like the different parameters that, that will tell us how to efficiently convert the light into the electricity, depending upon that parameters. So there are different parameters depending upon the like the VI characteristics of the solar cell. These parameters can be like how depending upon these parameters, like the solar cell, whatsoever the solar cell we are using, that can convert the light into the electricity. Parameters that tell us how efficiently the solar cell can convert the light into the electricity. So the first parameter based on this is the that is the short circuit current of the short circuit current of the solar cell. Short circuit current of the solar cell. So what is basically this current is we are having any solar cell, तो उस सोलर सेल की आपके पास कितनी मैक्सिमम कैपेसिटी है कि आपके पास वो सोलर सेल कितना मैक्सिमम करंट क्या कर सकता है, डिलीवर कर सकता है, और वो उतना अमाउंट ऑफ लाइक करंट डिलीवर होना चाहिए कि आपके पास सोलर सेल को उस करंट के डिलीवर करने से कोई भी हार्म ना हो. सो दैट मैक्सिमम करंट that should be considered. Okay, the current should be like that कि उससे आपके पास सोलर सेल को कोई भी हार्म ना हो. तो how that current can be measured, that maximum current, how that maximum current that we can measure, कि आपके पास सोलर सेल कितना मैक्सिमम करंट क्या कर सकता है, डिलीवर कर सकता है विदाउट हार्मिंग इट्स ओन. So in order to calculate that maximum current, what you have to do is that maximum current about which we are discussing, that maximum current that can be basically calculated by short circuiting the terminals of the solar cell. So we know how, like the we are having this is the solar cell by like we are having the two terminals by shorting these two terminals of this cell. This will be considered as an condition. Okay. Under this condition, what we can obtain is we can obtain like the maximum output can be obtained like by short circuiting the terminals of the solar cell. So there is we know the current production inside the solar cell that depends upon the area, upon the surface area that is basically exposed to light. कि आपके पास कितना area जहाँ पर क्या है आपके पास maximum light क्या हो रही है, expose हो रही है, that will decide how much current will flow. अगर आपके पास एरिया ही मिनिमम है आपके पास, तो जितनी भी लाइट एक्सपोज हो रही है या फिर उसको उतना एरिया नहीं मिल पा रहा है जहाँ पर आपके पास क्या हो रही है, लाइट पड़ रही है, तो दैट विल श्योरली डिक्रीज अमाउंट ऑफ द प्रोडक्शन ऑफ द करंट. So this is that is why it is important to express the we are we if we have to like express the current density, and you very well know current how the you can define the current density, that is defined by this is J represents the current density, that is basically given by the ratio of the current divided by the area. You very well know the formula of the current density. So this is given by the like this is the short circuit. S is representing the short circuit and the current density. Uh, that will be given by the ISC by the A. That is A is the surface area of the cell. Okay. Where ISC आपको क्या represent कर रहा है? ISC आपको represent कर रहा है, that is representing the short circuit current, and this is the maximum current density. So this is the one parameter for the maximum current density. That is the one parameter for measuring like how much current a solar cell can tolerate, okay, without harming itself. That is basically given by this equation. Next is the next parameter that is based again on the same as that is the open circuit voltage. That is the open circuit voltage of the solar cell. Open circuit voltage of the solar cell. So, what is this open circuit voltage? Which voltage we are considering as the open circuit voltage? Like we are having the cell, you are having the solar cell, and you are basically measuring the voltage. But here the condition is open circuit voltage. That is when no load is connected across that cell. At that point, if we are going to measure the voltage, that will be considered as the open circuit voltage when there is no load that is basically connected across the cell. So like you can say जो भी ये voltage है that वो voltage depend करेगी आपके पास uh, तो हमने कुछ कनेक्ट तो किया नहीं है, लोड आपने कोई भी connect नहीं किया है क्लोजर, तो ये वोल्टेज बेसिकली डिपेंड करती है कि आपके पास जो भी सोलर सेल है उसकी मैन्युफैक्चरिंग कैसे हुई है, उसका टेम्परेचर कितना है। तो आप ये नहीं कह सकते हैं कि इट विल डिपेंड अपॉन द लाइक आपके पास कितनी इंटेंसिटी ऑफ लाइट आपके पास उसके ऊपर एरिया किस उस लाइक उस सोलर सेल पर फॉल कर रही है, या फिर कितना एरिया आपके पास एक्सपोज हो रहा है। So it doesn't depend upon these two factors. So open circuit voltage आपके पास that condition when no load is connected to the cell, तो आपके पास जो normal open circuit voltage रहती है that you very well know in the case of the PN junctions, that is normally equal to the 0.5 volt or the 0.6 volt, and it is basically denoted by the VOC. So this is the open circuit voltage and one of the parameter for measuring for while considering the solar cell. These are the different parameters. Next is the maximum power point of the solar cell. Power point of Maximum power point of solar cell. Maximum power point of the solar cell. So as you know, like how to draw the VI characteristics of the VI characteristics of the solar cell. And depending upon the VI characteristics, we will find that maximum power point of the solar cell, like for what voltage and under what conditions of the current that will provide you the maximum power. What will be the value of the voltage and what will be the value of the current that will provide you the maximum power. That point where these you achieve these conditions, that will be considered as the maximum power point of the solar cell. For a second. So this is the maximum power point of the solar cell, which you can consider by the like the VI characteristics. Like you know, these are the VI characteristics of the solar cell. So this is the like the maximum current, and this value is representing the ISC, that is the short circuit current, and under what conditions of the voltage, maximum value of the voltage, this will give you the So, the maximum, like if we draw the VI characteristics of the solar cell, and the maximum power that will appear uh, from this point, like the current, you can see this is the IM current. Like this is the maximum current at which the maximum power occurs. That is the IM current. Okay, and again here is some voltage, that is the VM voltage, that will result into the maximum. This combination of the VM and the IM that will provide you the maximum power point. Okay. Next is the fill factor of the solar cell. Fill factor of solar cell. So write down one line for this fill factor of the solar cell. That is the ratio between the product of current and the voltage at the maximum power point to the product of short circuit current and open circuit voltage of the solar cell. So fill factor is basically that is given by, this is basically a ratio, that is basically the ratio of the maximum current and the maximum voltage, ratio of the product of the maximum current and the maximum voltage divided by the product of the short circuit current and the open circuit voltage, which we had already discussed before. That how you can obtain the value of this short circuit current and the open circuit voltage, and the open circuit voltage that is given by the VOC. So this the ratio of these two things will give you the value of the fill factor, that will provide you PM, that VM into IM, that can be written as the maximum power. So this is how we can write the value of the fill factor, that is the maximum power divided by the IAC into VOC. So this is the fill factor of the solar cell, and next parameter is the efficiency of the solar cell, that will be given by the efficiency of the solar cell. Efficiency of solar cell. And as you know, like efficiency, that is basically depends upon the output and how much output is obtained for the factors which we have applied as the input. So it will be defined as like the कितनी मैक्सिमम आपके पास इलेक्ट्रिकल पावर आउटपुट क्या हो रही है, आपको obtain हो रही है, और कितने आप पावर इनपुट कर रहे हैं सेल पर, या फिर कितनी लाइट आप क्या कर रहे हैं, एक्सपोज कर रहे हैं, डिपेंडिंग अपॉन दैट you can define the efficiency of the solar cell. That is the, and you know the how the efficiency is being denoted by the factor eta, that is the maximum power output to the power input, and in terms of the power, you can write it down as the PM divided by the Pn. So these are the some of the parameters that are basically defined for the solar cell. How you can basically characterize any solar cell, and how the parameters of these solar cells can be further defined. Okay, so depending upon the PN junction, how the semiconductor contacts are being formed, and how the energy gap, when the photons that are coming on the cell that have the energy, that is basically greater than the energy gap between the valence band and the conduction band, and by absorbing that energy, that one valence electrons, like they get excited from and jump to the other bands, and then after losing the energy, it can again form the electron hole pairs, and how this is how the in photoelectric energy that can be generated by the use of the solar cells. So this is about the parameters of the solar cells.